Let's get some more practice on solving exponential and logarithmic word problems. All right, in this case we have a very common application of an exponential word problem. An account with interest that is compounded continuously uses the same growth function that we've been working with on the last problem, and K is the interest rate, P is the amount, the principal amount, the amount initially invested, and T is the time in years. And what we're going to do is set up that function. So go grab your cue card. We've got the function here, A of t equals P times e to the kt. And let's jot it down on our paper. So we've got it ready to go. P times e to the kt. And let's make a list of the things we know and the things we don't know. So let's see, P, a principal amount. Let's see, the account started with $2,000. So that starting amount, that initial amount, is $2,000. So that's P. All right. What else do we know? We've got a time. We've got 5 years. So T equals 5 years. And we also have a resulting amount after 5 years. So that's, remember that A of t is the resulting amount. So that's 2755. All right, what we don't have, I'm going to put units on this. What we don't have is K. K equals, don't know. Okay, so what we're going to be doing is solving for what was that interest rate. Remember, K is always the rate of growth or decay, and that's the thing we don't know. So let's go ahead and rewrite our formula, our function, with everything we know. We know A of t is 2,755. We know P is 2,000. We know E is a number that belongs in the equation. We don't know K though, so we're going to leave that K. But we do know T. It's 5. Now, instead of writing K 5, I'm going to put the 5 in front of the K, because that's usually what we do. We put numbers that are to be multiplied by variables in front of them. So now we have an exponential equation we need to solve. We've got to get K alone because we need to find that interest rate. But we can't solve it in this form until, first of all, we need to get this base alone. So we're going to first have to get rid of the 2,000. Once this base is alone, we can put this in ln form, or we can take the ln of both sides, and that we'll be able to solve it. So undo times 2,000. 2,000 times this term that has this factor that has the K in it. What I do to one side, I do to both sides. So on the left hand side, 2,755 divided by 2,000, and I get 1.3775. Let's not round that because it's a nice terminating decimal. Let's put the whole thing down. Equals, now the 2,000s are gone over here, and that's just what we wanted, e to the 5k. Make sure you're writing the exponential parts up high and dry. All right, now if I want to undo this so I can get k alone, the first thing I need to get rid of is this base e. Well, again, what gets rid of e? ln does. Those are opposite operations on your calculator. So if I take the ln of both sides, 1.3775 equals ln of e, that will get rid of the e. ln eats e, down crashes the 5k, comes down to ground level, and on this side I can actually take the ln of this number. So I press my ln key, get the parentheses, put in 1.3775, close my parentheses, and I find out that I get 0.320 if I round it. Now I have to get k alone. The last step is to divide both sides by 5 to undo 5 times k. 5s are gone, and I get k equals, well, I still have that last number in my calculator, and I'm dividing it by 5. So I get 0.064. Alright, now the question is, what was the interest rate for the account? Well, this is the decimal form of the answer. We'd like to make sense of this in the real world. What percent is this rate? So if we look at this, times it by 100, or move the decimal 2 places to the right, or like I said, times it by 100, 0.064 times 100, and you get 6.4%. That's how we change a decimal back to a percent. Move the decimal 2 places larger, or times it by 100. So the interest rate on this account was 6.4%.